Greetings, hello, how you doing? This is KIN223. This is specific to chapter 2 from our book. And what I've done is I've broken out this presentation actually into several different subsegments. I tried to do it based on the material in the book and also time allowed or allotted in this format for doing this presentation. So without further ado, let's get going. So in this chapter, what you see is kind of the terminology regarding how do you take what you've learned in the book and then apply it in the practice. Make no mistake about it, you're learning a ton, you're in college, etc. But it becomes a concept of how you take that information and actively apply it, and that takes practice. And there's a terminology of bridging the gap that you'll often hear in the practice of the movement practitioners, whether it's strength conditioning, physical therapy, perhaps you're a different type of movement coach, a dance coach, for example. But you look at this in terms of how you're able to take this textbook knowledge and really apply it into a hands-on. But what happens is over time, you have your own personality, you have your own coaching style, you have your own abilities, and you have your own specialties. So to that end, you'll end up building your own coaching repertoire that'll be uh, inclusive of the material that you're learning in this class and others, presumably, but also the body of work that you'll have when you work with your population. So, science itself is part of this process. You have to have the ability to be able to take scientific data and research from others, if you will, and be able to actively apply it into your coaching environment. The thing is with the scientific process, it's systematic. It's a very controlled environment, and it's also one of those where it has a very strong kind of like critical filter, meaning when you do scientific research, it's not kind of off the cuff, I saw this and this is what the end result is. No, 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 no. The goal with this is, as you recall from your scientific methodology or even the scientific method when you were back in high school, was the ability to come up with a strategy to evaluate one variable and then be able to manipulate that variable. We'll talk about that in a second. But really the goal here is to be able to describe, explain, predict, and have an understanding or even can have allow the ability to control a certain behavior within a controlled environment. So the scientific approach and the scientific method, when you look at it, it's a way to standardize and a way to have all the conditions in the environment controlled except for the one variable that you're trying to work with. And it's very much based upon observation. You change this variable, you have this behavior, you evaluate, observe and evaluate the behavior, and it's very objective. It doesn't really allow for open interpretation. And it provides a strong critical analysis of the ideas to be able to have a body of work, if you will, when you create a scientific study. You'd like to have your results be replicatable, right? And also, are they valid and reliable? Those are the big words that you'll hear in the world of science when you start doing scientific research. Now, when you go down the list in the book, what I tried to do here is break this out where you have the systematic approach to studying questions, etc. Involves control of conditions for the key variables in the research, and then further on in the text they talk about it needs to be empirical, needs to be based off of observation. You're observing the result of a manipulated variable, and then it has to have like this kind of critical, rigorous evaluation. And with that, when you do research, when you're in a refereed journal, those results are actually evaluated by others in the field, and they'll read off on your research and then offer suggestions to you or approve of your research and agree with your research. And you'll see that even in the research world, you may come up with a study, you may get results, and somebody else may actually use your results to come up and formulate a different hypothesis to be able to either refute or accept what it is you've studied. Now, what you're after here is you're trying to come up with a theory, and it's a set of like facts that you'll be able to look at and say these things are interrelated, and if I do this, then this will happen. If I theoretically if I change this variable, excuse me, my theory is if I change this variable, I'll get this result. And it becomes a little bit more systematic, right? And it allows you to have a better understanding, but also a better ability to not only describe but explain what the results were from your study, but also then be able to look at and predict future occurrences. If I change this variable in this environment, then this should happen. If you do that in a study and you can replicate it, as I mentioned before, it's one of the key areas, and is replicatable, then that we should, with some level of confidence, be able to change variable X and we know we're going to get a certain response. And then the other part of this is you have a large data set. Now we have the ability now with like ChatGPT and others, SPSS and also Excel, to be able to really evaluate data. And it does become a conversation of how you can utilize this technology, whether it is Excel, SPS, or other programs that evaluate data, or even like I mentioned, now we have ChatGPT. We use large language models to be able to evaluate sizable amounts of data and really come up with ways to interpret it. Another format or software that allows that is R. Presents really exceptional ways to evaluate data and see data in a real visual context as opposed to just numbers on a page. So, there are different ways that we can do this, but the end result and the goal here is we're trying to find a theory or set of interrelated facts that present a view of some phenomena. And we want to be able to describe it going forward. So in this example, I just want to point this out. When you look at the different theories that we have in the book, there's a ton of them. And what happens here in chapter 1 is there's a bit of a divergence from what we were just talking about in terms of science and scientific method and coming up with theory. In the book, they start to go into this one in particular. They talk about the Zajanik study, where what he does is this. He looks at what looks to be a completely uncorrelated and unrelated set of results. And, sometimes people perform better in front of an audience, other times they perform worse. What he saw was a pattern in the data, and it looked very random otherwise. And what happens is sometimes, you see these patterns in data and you can create a study, or you create a study and then you end up with these data sets. And from the data sets themselves, you can start to evaluate. So it's like cart before the horse or the horse before the cart. But what ended up happening with this is he noticed that when people would perform tasks, let me get myself out of the way here, in front of an audience, scroll this down so you can see a little bit better. When people perform tasks in front of an audience, what ended up happening was they would either do really well or they would do poorly. And what he started to put together was it had less to do with the audience, although that was a driver, right? That was a variable. But what he found was whether they performed positive or negative, did a good job or bad job, was related more to the task at hand. But most accurately, it was related to how well the person knew the task at hand. So when a person was unfamiliar with a complex task, they performed poorly. When they were very familiar with the task in front of an audience, they actually did better. So it came down to that variable, not the audience being the variable, but actually the familiarity with the task at hand. So as we go through this, you start to look at this in terms of what a study is. Now, a study is just kind of observing the landscape. So in that Zajarnik example, what happened there was he just kind of evaluated and looked at the scenario itself. He didn't change any of the variables, but he just kind of evaluated and really assessed the environment. Now, the difference you have, though, is when we look at an experiment differs from a study insofar as we're manipulating one of the variables, right? So in this regard, you look at that situation where you have a crowd of people watching a skill and you're giving somebody a skill. The variable at hand is people are either familiar with the skill being performed or they are not. And the folks that were familiar with the skill did better. So that was your variable that was changed or manipulated in that experiment. There's a number of different experiments or a number of different variables you can change in that experiment, but just realize that the study is the observation of the environment. The experiment is what was changed. A very familiar one is the Hawthorne effect, if you want to look that up. In the Hawthorne effect, they evaluated ways to increase workers' performance in this plant in Hawthorne, in the town of Hawthorne. And what they did was they changed the fluorescent lights above, and what they found was in the areas where they changed the fluorescent lights, there was an increase of performance. It's called the Hawthorne effect. And so you could then maybe observe the environment, look at different areas where you can find areas of opportunity to increase performance, and maybe in one area you change the variable and your experiment is changing the lights. Another area your experience is the process flow of how they actually build something, or the height of the tables on which they are working. Those are the variables that you change, and that defines the context, or gives it the context to being an experiment as opposed to a study. First they had to study the environment, see what things they could change. They chose to change the lights in the Hawthorne plant, and the changing of the lights in the Hawthorne plant elicited the response that they thought was that people would have increased work performance. All right, so what I like about this in here is when they talk about the experiment, they further define that within a study, in an experiment, you have the experimental group, which receives the variable change, and the control group. In the Hawthorne example, the area that received the lights, the change of lights, was the experimental group. The rest of the plant where they didn't change the lights was the control group, and they compare the differences between the two in terms of their productivity. Now the big thing you have is this reductionistic concept where when you look at like that plant in Hawthorne, you can change all these variables all at the same time, but they chose just to change the lights. And when they change the lights, they're focusing on that variable. But by definition, they're focusing on that one variable. And so as a result, this reductionistic mindset is that you end up almost like with a tunnel vision where when you conduct a study, then you focus on one thing too much, and it's at the expense of everything else downstream. You know, table height, lights, tools that people work with. You know, these are all things that are variables that can be changed, but what they're trying to focus on is this one area. And this one area can have a sizable effect to the process downstream or even leading into the change of variable. So you have to look at this in terms of there's usually a flow through from one process to another, from one variable to another, and you have to look at the interrelatedness of those. But when you do a study, many times you're just focusing on just one variable itself to change. So when you now go from evaluating to actually doing an experiment, that's when you change that one variable. So to that end, I'm going to break here, and we'll go into the next video in this chapter.